Hello, I'm Arun, and thank you so much for giving me an opportunity to interview with CodePath. If students ask me any questions that I don't know, I think the first thing that I can do is I will encourage other students within the group to answer that question if they know. So what will this do is this will create an interactive and discussive section within the pod, and I think this will be a really boost for other students to answer that question if they knows. And if I don't know answer to that question, but if I know the answer can be found in any resources in the internet or any code path slides, then I will direct them to that particular slides or internet resources. And what this will do is this will encourage students to find the answer themselves rather than just me telling them the answers directly. And I think it is a excellent opportunity for students to find the answers through the internet. And as a computer science student, it is really a useful skill. And the other thing that I couldn't do is if I don't know answer at that point of the time, I can just say at this point of the time I don't know the answer, and I will reach back to them later. And I can even find answers in the internet resources or talk with other TAs to find the answer and later provide them with the internet resources where the answer could be found. So these are the something that I will be doing if I don't know the answer. So for the second question, if students do not open the camera, the first thing I want to do is I want to create a welcoming environment and do something like icebreaker and ask them about their heavy hobbies or anything that they did recently. I think this initial conversation will create a environment where everyone will be comfortable, and maybe students will be comfortable to open their camera. So this is something that I could do. The other thing I can do is to tell the importance of opening the camera and telling that opening a camera will really help to create a very interactive environment that will help even other students within the pod to open the cameras and learn interactively. And the third thing I could do is, as I said, create an interactive learning environment by doing some small group decision within the group and creating some polls or quizzes. So by creating an interactive lesson, I can also make this session more interactive. And by doing this thing, I want to make students open the camera and want to make the session more interactive. And even if doing this doesn't help, I think the best thing that I could do is I know CodePath has some rules that students need to open their cameras to within this class, so I can direct them through the slides where these rules are mentioned and ask them to go through the this information, because as a student of CodePath, it is very important that students open their cameras and be part of this interactive session. So these are all the things that I do want to do if any students does not open the camera. So for the third question, explaining the binary search algorithm, I have prepared some slides. So I just want to go through the slides because I feel that uh, understanding the concept is really important. And if students are able to understand the concept, then writing the code should not be a really hard part. So I have prepared some slides. Let us try to go through the slides and try to understand what really binary search is. And then after that, we will also go through the code and do a bit of demonstration. So let me just go through the slide. So let me share my screen. And I hope you can see my screen, right? So here we are trying to understand binary search, right? So the first question even we can ask is, why do we need binary search, right? So so before even understanding binary search, let us try to understand something called linear search. And if we are able to understand the linear search, then the importance of binary search can be understood more properly. So let us firstly take some minute to understand the linear search, okay? So linear search. So let's assume that we have the list of numbers, right? I have the list of numbers, and the one thing I do want to ask is, how do you determine if number 31 is in the list or not? So the first thing that you can do is uh, you can just the first thing that you can do is just go through all the numbers, right? Like you can check if 4 is 31 or not, 1 is 31 or not, 20 is 31 or not, right? So you can just go through linearly, right? That's the human approach. That's the initial approach that everyone wants to do, right? So what would be the best case there? So luckily, the 31 can be at the first uh, index, right? Then you can easily find. You don't have to search through all the list of numbers, right? But there might be also another cases, right? Where so what would be the worst case? Let's assume that the number 31 is in the last, right? And in that case, basically you have to go through all the numbers, right? And let's imagine, you have like 1 millions of numbers in the list, then in that case, right, you have to go through all the million of numbers to find that 31, right? And just imagine, how much time consuming this could be. So this is a time consuming process, just checking every numbers one by one, right? So there should be another alternative option to find the numbers more effectively, right? And that is where binary search comes handy. Binary search is more effective as compared to the linear search we just described. So let us try to understand binary search and how does this become more effective as compared to the linear search. So just imagine, right? Like right now we have the numbers, right? What if this number is sorted, right? We can sort the numbers in ascending order, right? So this was our initial number. Now I just sorted them, right? So now you can see the numbers are sorted and they are increasing the uh, increasing order, and 31 is red, meaning that we want to find this number. So do we, we can we use this, sorting order, this sorting information to our advantage? Yes, we can use, and that is where the concept of binary search comes into the play. So let us try to understand how does this work. So what we really want to do is, here the rate suggests that we want to find 31, right? So because this number is sorted, right? First of all, what we can do is we can find the middle element of that particular list. So what is the middle element, right? So 1 is in the leftmost side, 50 is in the rightmost side, right? And as you can see with this gray color, 23 is in the middle, right? So what we can do is just compare, right? If this middle number is smaller or bigger than the target number that we are dividing. So here, so just see if this 23 is bigger or smaller than 31. Well, 23 is smaller than 31, right? So it is very certain that, right, the 31 lies on the right side of the 23. So we can just say, we can just look on all the numbers on the right side of the 23. So what do I mean by that is, if we just go right, can you see this dark number? So we don't have to look anything on this part because we know that, 23, 31 will always be on the right side. So this is the logic. We just have the list of numbers. We take the middle numbers and try to compare with the target numbers and do our logic. And we want to continue this process again and again. So right now we don't want to look anything on the left side, and the next middle number would be 32, right? Out of this remaining elements on the right side, and again compare 32 with 31. Well, 32 is greater than 31, so I want to leave everything that is on the right side of 32 and do this process again, right? So again, what would be my next middle number? My next middle number would be 27. And again, compare 27 with 31. Well, 27 is smaller than 31. So what I can do is I can eliminate everything that is on the left side of the 27, including 27, right? So I have to find the new next middle number. My next middle number is 28, right? And just compare 28 with 31, which is still smaller than 31, right? So I can go again, I can eliminate this number and go on. Boom. At the end, right, we found this 31. We come to this point where 31 is the number itself. So if there is any case, where we find 31 and middle element same, we know that that number exists, right? And basically this is effective because at every point of the time we are eliminating half of the numbers, right? In the linear search we were going through all the elements, whereas in this binary search we are eliminating half the numbers. So this increases the speed of finding the numbers, right? So this is what about binary search. And so this is about the concept, right? So now let us try to understand this thing in terms of code. So what we can do is we can create something called low, which would represent the left side, and high, which would represent the right side, right? And we can calculate the middle number just by doing low plus high divided by 2, right? That is basically finding the middle of using low and high. And let's say, there could be three cases, right? The first case is, let's say, our target is 31, right? There could be one case where our target element might be greater than our middle element, right? In that case, we just make our low as mid plus 1 because we want to keep our left pointer. We want to throw all the elements in the left side, right? So by making low equals to mid plus 1, we throw all the element. So this is one case. The other case is, there could be another case, right, where target might be less than middle element. If target is less than the middle element, we know that the element is present in the left side, not on the right side. So what we can do is our high can be mid minus 1. So we just change the pointer, right? And there could be another cases where so there could be another case where our target element might be the middle element itself, right? And if this is true at any point of the time, we can return the index, right? So these are three cases we need to be really careful about. And if we are able to do that, then I think we can solve the problem. So one thing that we want to understand here is, like there could be any cases where 31 might not be present in the list, right? So when do you want to continue doing this, right? So we want to continue doing this until and unless, our left pointer is here, our right pointer is here, right? So left and right just goes together, and we want to do it as long as, while our left pointer is smaller than the high, because while our left is smaller than high, right, we have some possibility of finding the answer. And as long as, left becomes greater than high, we know that, there is no another element. So we want to search as long as, my lower pointer is smaller than the higher pointer. So this is all about the concept. So let us try to go through the code and understand how does this look into the code. So I have a code for this. So this is the code for binary search. Uh, this is the list of numbers I'm trying to provide, and this is my target number 7. And yeah, so basically I have my low, which is so low starts with 0, right? And high starts with the rush number. So if you can see here, this basically means my low, which is represented by L, is on the leftmost part, and my high, which is represented by the rightmost part, is here, right? And my code, which is works until and unless my low is less than high, right? So this is the important condition here. So the first thing that I said was we want to calculate the middle element, right? So how do I calculate? As I previously said, calculate low plus high divided by 2, right? So in this case, the low's index is 0, and this is 5, right? So that is 0 plus 5 divided by 2 is 2.5, and when we round it, we get 2, right? So that is 0, 1, 2. So my middle would be here, right? So this is my middle, right? Here is my middle, and my target number is 7, right? Now I will start comparing. So I will do, hey, if my array of mid is target, my target is 7, is my mid 7? No, it's not, right? Then I want to compare if this middle number is smaller than target or greater than target. So here I'm doing, hey, if my middle number is less than target, my middle number is 5, my target is 7. Well, this is a true condition, right? My 5 middle number is smaller than the target. So what do we want to do this point? We want to make my low is equals to mid plus 1. My low is currently here, my mid is here. So what does mid plus 1 means? My low would be mid plus 1. So mid plus 1 means this position. So my new low would be here, such that I can remove this. So you can see, right, how this thing changed. My low was here, now my low came here. So this all code went through, and again I will execute the while loop, right? And again I will compare if my low is less than or equals to high, which is a true condition, right? So it means that we can use the while loop again. And again I will compare low plus high. Well, the middle element in this case should be here, right? This number, and I can remove this number here. So my middle number is 9, right? And now I will compare, if my middle number is greater or smaller than the target. Here we can see my middle number is not smaller than the target, right? So we can't execute this condition and this condition. So this is the condition that is working because my middle number is greater than this number, right? So what do we do in this case? We do high equals to mid minus 1. Well, my high is here, my mid is this, mid minus 1 means my high would come here, right? So basically my high would also be here, and my high would go from here, right? So now my low and high is at the same point, right? And again, the while loop will work. I'm doing while low is less than or equals to high, which is a true condition, right? Because low and high are equal at this point of the time. Then we want to compare, hey, if array of mid is equals to target, which is a true condition because my mid is also, if we calculate the mid becomes this number itself, right? Array of mid becomes the target number, which is a true condition. That I want to return mid. So I'm going to return the index of this position, right? So this is how the binary search works. And if we are looking for any number, right? Let's say 6, right? Then at this point of the time, we would not find this number, right? Then basically my high would go here and my low would go something here, right? And that would violate the condition for the while loop, and we would return the -1 statement. So that is about the binary search. I hope with the slides and this explanation you were able to understand what binary search means. Thank you so much.